the Viète-formulae. Let's have a look at an example where you have to work out the sum of the roots of a given quadratic equation. The sum of the roots, given that the roots are x1 and x2, will be x1 plus x2. This is what we are looking for. But before we start working on them, we have to check, or it is practical to check, whether this equation has roots at all. That is, we need to check first of all the discriminant, and if it's not less than 0, then it will have roots, so we can start working. Now the discriminant, given that a is 2, b is minus 1 and c is minus 2, will be 17, which is greater than 0, and that means that this particular equation has 2 roots. So we can start working on the sum of these 2 roots. Now using the formula and substituting in the formula, now you don't have to start to work out the discriminant once again, that is what we have under the square root, but you can straight away put the 17 under it. And this way you can see that the 2 roots will be 1 plus square root 17 over 4, while the other is 1 minus square root 17 over 4. If you're not simplifying it any further, because we can't, and we are not giving an approximate value, you'll see why, because we are going to gain a nice solution if we don't round. Now let's take the sum of the 2 roots. If you take the sum of these 2 roots, you can see that we have already got a common denominator, which means that we can put these on the same bar and collect everything in the numerator position. If you have a look at the numerator, you can see that we have the plus square root 17 and the minus square root 17, which luckily will cancel. Therefore, in the numerator we have 2, and in the denominator the 4. So simplifying this, we get a half for the sum of the roots. Now, is there a quicker way to work this out? Yes, there is. I can already give you the answer. But before we apply this quicker way, we'll have to have a look at the general form of the quadratic equations and their roots. And we have to do the same steps, just like we have recently done, so as to see what the sum is always going to be equal to. Now here we have the quadratic equation in its general form, and it's important to point out that a is not 0. Then the roots are going to be minus b plus square root the discriminant over 2a, and minus b minus square root the discriminant over 2a. And given that the discriminant is non-negative, so given that we actually have roots, we can start working at the sum. The sum of these 2 roots again can be collected by putting them first on the same bar as they have a common denominator, 2a, and collecting everything in the numerator. You can again see that the square root of the discriminant is once here with a plus and appears once with a minus, therefore they will cancel each other. If you collect minus b in the numerator, you get minus 2b over the given denominator, 2a. Simplifying this, you get minus b over a. And this is always true given that the discriminant is non-negative. So we do not need to work out separately the roots and then determine their sum. But from this point on, we can use the fact that their sum is minus b over a, given that b is the coefficient of x and a is the coefficient of x squared, and given that it's not 0. Now let's apply this on the previous example. 2x squared minus x minus 2 equals 0. Now let's determine their sum, the sum of the roots, given that they can work that using the coefficients b and a. So putting minus 1 in the place of b and 2 in the place of a, you can see that we indeed gain a half, just like we gained before. So this method works. Now let's have a look at what if you have to determine the product of its roots, and let's consider the same equation. Again, if it was an individual task, and if it was a task on its own without determining the sum of its roots, you would again have to start with checking the discriminant. We have already done that. The equation has two roots we have shown. Now let's apply the quadratic formula to work out the roots first and see what the sum of the what the product of the two roots will be. Now, as I have already shown you, the two roots are 1 plus square root 17 over 4 and 1 minus square root 17 over 4, which we do not simplify. Taking their product, you have to multiply two fractions. Then you do it as we did it in the case of normal or easier forms of fractions, so numerator by numerator and multiplying denominator by denominator. But you should not forget about the brackets around the numerators, as both of the numerators are two-term expressions, so it's essential to have the brackets. Now this is an identity, a plus b times a minus b, which equals a squared minus b squared, that in this case is 1 squared, that is 1, minus square root 17 squared, which is 17, and this whole thing is over 16. If you work this out, it's equal to minus 1. Very nice solution. Now again, we are going to check if we can get it in a quicker way. Again, we return to the general form of the quadratic equation using the quadratic formula as well, and considering that the discriminant is non-negative, we multiply the two different roots. One is with the plus and the other one is with the minus. Now multiplying these two, we have to follow the same steps basically as we did in the previous exercise. So you multiply numerator by numerator, denominator by denominator. That results in 4a squared in the denominator position, and you should not forget about the brackets around the numerators if you multiply them, which will again be an identity, a plus b times a minus b, that is a squared minus b squared, which in this case is b squared minus, and brackets around b squared, because well, the square root will disappear due to raising it to the power of 2, but you need the brackets as we have two terms under the square root. If you expand these brackets, then the minus in front of the brackets will change the sign before 4ac into a plus. Then you can cancel the b squares. If you collect them, it's 0. So that equals 4ac over 4a squared, simplifying which you get c over a. So again, we have gained a simpler formula for how we can work out the product of the roots of a quadratic equation. And that's going to be dependent on the constant term and the coefficient of x squared. So c and a. And again, we have to point out that a is not 0 and the discriminant of the equation is non-negative. Now let's apply this on the previous example. We have already checked the discriminant when we determined the sum of the two roots, so we do not need to do that once again. And then we can apply the formula we gained, x1 times x2 being equal to c over a. c is minus 2, a is 2, substituting which you get minus 1 for the product. Now this is much quicker than working at the roots separately and then taking their product. These two formulae that we have gained, one for the sum and one for the product of the roots, are called the Viète-formulae. Viète was a mathematician. You can read about him on the internet if you're interested. But it's, again, I would like to highlight, very important, that in the general form of the quadratic equation, a is not 0, and also an important condition is that the discriminant of the equation needs to be greater than or equal to 0, which means it is essential to have roots to be able to work out their sum and their product. The Viète-formulae can be worked out in another way as well, using the general forms of the quadratic equation. The general form, the expanded one, and the factorized form as well, in which the two roots appear. You have to remember that a is not 0, otherwise it's not going to be a quadratic equation. Now, as we know, these two have to be equal, just written in a different way. So first of all, we can rearrange it as if it was an equation. Let's start with the division by a. Because we know it's not 0, we can divide by a. On the left side, the coefficient of x squared remains 1, while b is going to be divided by a as well as c is divided by a. On the right side, we just simply get rid of the a, and it becomes 1. Now we expand the brackets on the right side. You multiply everything by everything. You get x squared minus x1x minus x2x plus x1 times x2. In which case you can collect the like terms, the 2 in the middle. If you take out minus x, then you can see that we basically have x1 plus x2 times minus x. We can put the x behind the x1 plus x2 term, because the order of the factors of a product can be changed. So written in this form, we can compare the coefficients of the quadratic, the linear, and the constant terms. Now, because the two sides are equal, we can say that b over a has to be the same as minus x1 plus x2, while c over a has to be the same as x1 times x2. And here you can see that these are the two Viète-formulae. So this is the other way to get them. Now, how can we apply them? We can, for instance, apply them when we are looking for other combinations of x1 and x2 and not just the sum or the product of the two roots. Let's work out the sum of the squares of the roots to show an example. This is the same equation, 2x squared minus x minus 2 equals 0. Therefore, we have already shown that the discriminant is greater than 0, therefore it has two roots. So we can start working on it. Now, how can we work out the sum of the squares of the roots? Where do we have squares of anything? If you remember the identity a plus b squared, that equals a squared minus 2ab plus b squared, in which we have a squared as well as plus b squared. Now, if we apply this identity on the roots, this is what we get. Now, why is this helpful? It's helpful because here appears the sum of the two roots, which we can work out easily using the coefficients a and b. Here the product appears, which we can again work out easily using the constant terms c and a. And then x1 squared plus x2 squared is what we are looking for. Now let's apply the Viète-formulae. Let's work out x1 plus x2 and x1 times x2. The first one is a half, as we have already seen it. And x1 times x2, we also have already worked out earlier, equals minus 1. Now let's substitute these in the formula or in the identity. On the left side, we'll have 1 over 2 squared. On the right side, we'll have x1 squared plus 2 times minus 1, which is the product of the roots. And we still have the plus x2 squared. Now, simplifying this and collecting all the numbers on one side, you get that the sum of the squares of the roots is 2 1/4, which is 9 over 4. Now this is how we could apply the Viète-formulae to work out the sum of the squares of the roots.